All right, let's get right into it. Today, we are opening the case file on a really mysterious visitor, a traveler that just zipped through our solar system from another star, and it's left scientists with a story that just keeps getting stranger.
Yeah, this is not your average story about some distant piece of space rock. As we're about to find out, this object, known as 3I/Atlas, has thrown a whole bunch of curveballs at astronomers, things that challenge pretty much everything we thought we knew about comets. This is a real-deal cosmic investigation.
So to really get a grip on just how strange this visitor is, we first need to kind of set a baseline. What does a normal comet even look like? And what's the big deal about an interstellar object in the first place?
Okay, so at its core, a comet is basically a dirty snowball. It's just a leftover chunk of ice, dust, and rock from way back when a star system was born. And when it gets close to a star, like our sun, things heat up, that ice turns right into gas, and it creates this fuzzy atmosphere. We call that a coma, and of course, that iconic, beautiful tail.
And right here, you can see the huge difference. The comets we're used to, they're locals. They orbit our sun in these nice, predictable loops. But interstellar objects, well, they are messengers from other stars. They're on a one-way trip through our system, which means they're pristine samples of what another solar system is made of. Getting to see one is incredibly rare. In fact, 3I/Atlas is only the third one we have ever confirmed. Ever.
So, let's open up the evidence file on 3I/Atlas and see why scientists are scratching their heads. The story here isn't about one weird thing. It's about a whole stack of them that just don't add up.
Get this. When you take all the bizarre characteristics of 3I/Atlas and you put them all together, the probability of it being just a normal, natural comet drops to less than 1 in 10,000. I mean, those are the kinds of odds that make scientists sit up and really pay attention.
This is really the heart of the mystery. Let's just run down this list of clues. First, its path was perfectly lined up with the orbits of our planets, a 1 in 500 long shot right there. Then, it fired a jet of material towards the sun. That should be impossible. Solar wind always pushes a comet's tail away from a star. Its chemistry is just bizarre, more nickel than iron and barely any water. Even the way it reflects light, its polarization, it breaks all of our models for natural dust. And maybe the biggest clue of all, it shed 4 billion tons of material as it got close to the sun. But the massive tail we should have seen, it was completely missing, gone.
So what's the conventional explanation? I mean, faced with this pile of weirdness, a lot of top scientists are arguing that, okay, while 3I/Atlas is definitely strange, it's still a natural, just, a highly unusual phenomenon.
As astrophysicist Brian Cox put it so well, the idea of just seeing a pristine piece of another, maybe long-dead star system, that's wonderful enough all by itself. The argument is that we don't really need to jump to aliens to explain what is already just a magnificent natural wonder.
And the main point here is that for every weird thing on that list, there's a potential natural explanation. Maybe it's just a statistical freak of nature, or maybe it formed in a star system with a totally different chemical recipe. There's this one fascinating idea that it's an armored comet, where millions of years of cosmic radiation basically cooked its surface into this dry crust, trapping all the normal comet stuff inside. And that missing tail? It could have just been made of gas that's really, really hard for our telescopes to see.
But the sheer number of these anomalies, all of them happening in just one object, has led other serious scientists to ask a much more provocative question. What if 3I/Atlas isn't entirely natural?
Now, this isn't just some chatter from the internet. Harvard astrophysicist Avi Loeb has publicly raised the hypothesis that this object could actually be a piece of technology. He argues that when the data consistently goes against our natural models, we have a scientific duty to consider all the possibilities.
And if you look at it this way, the anomalies start to seem less like coincidences and more, well, like a plan. Its path was a perfect tour of our observation posts at Mars and Venus. Then it hid behind the sun at its closest approach, the perfect spot for a secret maneuver. And its incredible speed in its orbit, going against the flow of the planets, make it almost impossible for us to chase. Even that weird nickel-heavy composition is suspicious. It's more like the industrial alloys we use for spacecraft than what you find in natural space ice.
So where does all of this leave us? Well, right now, the case file on 3I/Atlas is wide open, and there are really compelling arguments on both sides.
Its journey through our system was so brief, but it was historic. Discovered back in July 2025, it gave our Mars probes a close look in October. It swung around the sun, and then by January 2026, it was already on its way back out to interstellar space, never to be seen by us again.
And at the end of the day, that's the real takeaway here. Whatever this object was, a 1 in a billion natural wonder or something else entirely, it was an incredible gift. It has challenged our models, it sparked a really fierce and necessary debate, and it totally pushed the boundaries of what we thought was possible out there. It really just leaves you wondering, right? As our telescopes get more and more powerful, we're going to find more of these interstellar visitors. And if 3i/Atlas has proven anything, it's that we need to be prepared for surprises, because the universe is under absolutely no obligation to meet our expectations. Thanks for digging into this cosmic mystery with me.